Hello everyone, let's continue to talk about positioning vectors. Okay, let's look at this example 20. Okay, so in this example 20, so basically we have draw some lines and points on this diagrams. Okay, in the diagrams above is a Cartesian plan. So we have AED, and BEC, and the BEC, they are the straight line. It's a straight line. Okay, so we already given the question already given. The point A has a coordinate -a and 0. Okay, this is already the coordinate. The origin is O is here. So we also know the point C is coordinate is 4 and 9. Okay, and also given is AB. This vector is in the column form is 12 and -6. That is the vector AB. We also know the CD. The CD is equals to the 2/3, 2/3 of AB. Okay, so that is, in fact, this is one of the very important information. Okay, this is very important information here. Okay, so what's the question? The question is to find the coordinates of the point BDE. So where's the coordinates? The B, D, and the E, right? To find out all those points, what is the coordinates for those things, right? What's the coordinate of these things? So we already know A and C. So we need to find out the BDE, right? And the second question is the ratio of the area ABE, this area, and compared to the other one, the DCE, this area. Okay, so that's very important information here, right? Okay, we already underlined. So we know 2 points, A and C, and then AB, the vectors, column form. We also know CD is equals to 2/3 of AB. So that is very important information here. So from here we can see that, in fact, AB is parallel to the CD, right? So if you write everything in this form. Okay, so now let's look at a solution. So let's look at the first one. So how we find out the coordinate for the B? Okay, so B. Okay, the first one is the B, right? The B's coordinate. So how we write that? We can write a coordinate. Okay, maybe XB and a YB. Okay. We write in this way, XB and YB. Okay, so from here then, okay, so from here, okay, since we know that B is XB and YB, so we also can know that is OB, because O is the origin of this in this Cartesian plan. So from here to here, we also can write in this way. So we can write in the column vector XB and YB, right? So now we have to find out this. So what is the coordinate of this B, right? Okay, so and then things because of what? Because of this. Let's look at the triangle. Okay, we just visualize this. Okay, we have a one triangle. ABO or AO. So let's look at in the triangle. So ABO. Okay, let's look at triangle ABO. Okay, inside this triangle, so we can see that is the OA equals to what? Our answer is the O. We have to find out OB, right? So in this case, we just write OB. Okay, OB. Use the triangle law. So OB equals to what? OB equals to OA plus AB, right? This is the triangle. Right, just assume in this triangle, inside this triangle, so we use the triangle law, right? We use the triangle law. Okay, let's continue. So we already know OA. OA is how much? We already know OA, right? So, okay, if this is the case, since we already know OA, so we will just bring the OA. OA in the OA is this point, okay? OA is this. OA is minus A0 plus AB. So with AB were given, right? AB is given, right? So it's 12 minus 6, right? So what's OA? What's OB? OB is XB and YB, right? Okay, this is our question, right? So from here we can see that, okay, just use the simple addition of the two vectors. So we just bring them in. Is it plus 12, right? 0 plus minus 6, right? So what is the answer? The answer is this 2 plus is a 4. From here, just bring minus 6, right? So can we find the answer? Okay, that's 4. XB equals to what? XB equals to 4 and equal to minus 6, right? So what's the coordinate? The coordinate for this A, so the B point, the point B, the point B coordinate is what? The point B coordinate is 4 and minus 6. So that is the answer, right? So from here we can just write here. We can write here 4 and minus 6. So that's the answer. Okay, we find first coordinate point, coordinate this, right? Okay, let's remove this. Okay, we already read that. Okay, let's remove it. Okay, let's continue. The next one, we have to find out the D, right? Okay, coordinate D. The D is the same thing. Okay, we just gave that. The coordinate, the point D is XD and YD. So, okay, this point D in terms of the reference point, origin point O. So we can write OD equals to what? XD and YD, right? In the column vector form, right? Okay, so then let's look at we just found one triangle for this D. Okay, so which one we can use it? Okay, now from here we already know the C and D, right? We can easily work out the triangle. Okay, so we already have okay, let's see that. Okay, for example, in this triangle OAB. Okay, let's say let's say for this triangle OAB. Okay, so OCD. Okay, OCD. Okay, in this triangle, so what's the relationship for this D and C? Okay, the relationship OD equals to what? OD equals to OC plus CD, right? Is it correct? Okay, so that is the relationship. Again, we use the triangle. Right, we use the triangle again, right? Okay, so just bring the OC. So what's the OC? We already know the OC, right? OC is, so what's OC? 4, 9, right? So, okay, never mind. So what's the CD? CD equals to what? CD, just now we see here, right? It's already given, right? CD equals to 3.2 of AB, right? So this is the very important information, right? Okay, this is already given. So from here, we write 4, 9 plus 3/3. Okay, so what is AB? AB is 12 and minus 6, right? We're just bringing this information here, right? Okay, this is known information. Okay, now we just do the multiplication of this vectors from here. So 4, 9 plus, okay, we just bring them in. So on top is 12 times 3 minus 6 times, so what we get? What we get here? So it's 4, right? So here's 8, here's 2, right? So minus 4, right? Okay, so that's the thing we get, right? Then, okay, we just use a simple addition of two vectors. So we do that 4 plus 8, 9 plus 4 minus 4. So what we get? Here is 12, right? And then the below, okay, equal to 5, right? So that's the answer, right? So we can get that, right? Okay, so since since the coordinates this xd and yd, so what we get xd equals to 12 and the yd equals to 5. So we get the answer, right? So it's 12 and 5. Okay, we just transfer answer here. This is 12 and 5. Okay, we get answer already, right? Okay, that is the coordinate. The point these coordinates 12 and 5. Yeah. Okay, that is very clear, right? Okay. Again, we use the triangle law. Okay, let's continue about E. Okay, in terms of E, this is very interesting. Okay, E. Okay, E we also give the coordinates for the point E. So we just gave the coordinates the xe and the ye, right? Okay, and in terms of the OE, so what's the OE? So in terms of OE, we can express in this way. So OE, we can express the xe and the ye. Okay, so that's very clear. Now, okay, so we have to find out the relationship between these two. Okay, so you see, okay, how to find out the E? To find out the E, we must find the relationship between either the straight line, because AED is a straight line. So, and then BEC also a straight line. We must find out the relationship of the point. So, need to use relationship of E and point A and the point D, right? In this line. Okay, so we have to find out a relationship between on this line, either this line or this line. Okay, in this case, we much more easy. We just focus on this line. Okay, since we already have these 2 points, so we have to find a relationship on this E since it's on this line. So because this is already given, right? Given here, there's a straight line, right? So okay, so we have to find a relationship between the point E and the line AED. Okay, maybe we can get more clear. The point E and the line and the straight line AED. Okay, so that is the K, right? So we can find out the K is this. Okay, now, okay, because CD is equal to 2/3 of AB, right? That is very important information because it's not very given. Since this is given, so we can know. So what we can know, because this is in terms of vectors. When we have this formula, we know that okay, CD is parallel to the AB, right? CD is parallel to the AB, right? Okay, and also okay. So we from here we know that okay, and the length of this. And the length of this also is the CD equals to the, in terms this is the direction. Okay, this is talking about the direction, and this is talking about the magnitude, right? So let's remember the vectors definition. So they are parallel, and they are same. That the ratio of the magnitude also is to CD equals to the 2/3 of this AB. Okay, so this is very important information in terms of vector. Vector have a dimension, right? Okay, they parallel each other. So from here, okay, since we have this information, so and then we also have this in the triangle. Which triangle? In the triangle ABE and the triangle triangle DCE. Okay, so this triangle ABE and the DCE, right? So these two triangle. Okay, so these two triangles. Since we know that these two lines has the information, right? We have okay, so from here we know that okay, in the triangle, because they are also parallel. Okay, so from here we see that the first one, okay, the BAE equals to CDE, right? This, so the BAE, okay, BAE, this angle is equals to the CDE, right? Right, so this, because they are parallel each other. Okay, and then the other line, okay, we also know that, okay, it's AEB equals to the DEC, right? So the AEB and the DEC, because these are the two line, right? So this line apparently they are equal. Okay. So from here we see, because this use apparently is using all those there is two line, right? Okay. So there are two line. Okay. So and from here, then we can find out. Okay. Since two angles, there are two angles that equal each other. And also there and there's one more line parallel, and then also becomes the 2/3 of this line, and this line and this line are 2/3. So from here we can give a conclusion, right? So triangle ABE is similar to the triangle DCE, right? So we can easily find out this answer, right? So from here, okay, since these two triangles are similar each other, so we also can continue to find out. Okay, since the AE over ED. So what's the ratio? This ratio also must equals to the AB, right? AB over the CD, right? This time and this time. In fact, so there's also another one. In fact, another one. So we also can find out is the BE and EC. So they are also, in fact, they also have the same ratio, is the 3/2, right? Okay, so that is ratio. From here we can just come out here, right? Okay. In fact, we can write it the other way. It doesn't matter because from this ratio we can come out. Okay, so maybe we can write more clear. Okay. Okay. So because they are similar, so we must see CD over AB is how much? Is 2/3, right? Okay, so because they are similar, we also can have this answer, because the same line. We also can find out is that AE. So and the ED. Okay, then we also can find out this and DE over the EA over the AE, right? We also can find out, in fact, we also can find out is the CE and the BE, right? So they are all equals to this. They have the same, because they are similar, so we can find out this. Okay, and similarly, we just continue. Okay, let's continue. So AE, so what can we find out? So from here we see, okay, because our focus is the line of, our focus is the line AED, right? So this is our focus line. Okay, so from here we can see that. Okay, so what's the ratio about the DE? Let's say from the AD. So from the AD, let's say the AD So from here we also can find out is that AE over AD. So what's the ratio? So the ratio will be the AE over AE plus the ED, right? Is that correct? So from here we know that, okay, this is 3, right? This is the 3, right? And this is the 3 plus 2, right? Okay, then we get a ratio is 3/5. Okay, so which means AE is compared to the AD is 3/5 because there's 2 here. So we get a ratio here, right? So now we get a ratio. Okay, so this is a very important this is therefore AE equals, because they're on the same line, so then we have 3/AD because they are a line. Okay, ADE is a line, is a straight line, right? So we get this ratio. Okay, this is very important information. Okay, so from here, so this is very clear, right? So use this relationship. Okay, use this relationship. Use CD. Use this one. CD is equals to 2/3 of this AB because these are vectors. From vectors, we can say this typically they are the parallel each other because the direction is the same. And in terms of magnitudes, they also have these 2/3 relationships, right? And also from here we see, okay, because these two, we can just come up, okay, that's very important concept. These two triangles actually are similar each other. So from this relationship, we can find out, okay, the AE, okay, A is 5, and the ratio, in terms of ratio, A is 5, and the AD is 5, and the AE is 3. Okay, so we get this relationship. Okay, this is clear, right? Okay, let's continue. Okay, because this since we already know that, okay, the ABE is similar to the triangle DCE, right? Okay, because this relationship, and just now we also work out, right? Just now we also work out AE equals to the, right? Okay, right? Because they are same line, right? Okay, so from here now we know a very important concepts. Okay, to work out the E, okay, the E, okay, to work out the E. So let's draw the relationship between these two. Okay, see, so how we work out this relationship, right? So and then this okay, AE. So what is the AE? What's the relationship of the AE? So AE equals to what? So what is the AE? AE is, so use the triangle law. AE. Okay, so maybe I just express. Okay, so AE in this triangle, the triangle of the AOE. In triangle AOE. So what's AE? A equals to what? AE equals to AO plus OE, right? This is a triangle law, right? Again, we are using triangle law. Right? We're using triangle law, right? Okay, so that is quite clear. So and then this of course, we already know the OA, right? We know the OA. So this is also equals to what? Minus OA plus OE, right? So in this case, this is OE minus OA, right? Okay, so this is clear. And the second thing is, right, in another triangle. Okay, let's look at another triangle for OD. For the AD. For the AD is what? AD, we know the AD. AD in another bigger triangle, okay, AOD, okay, AOD, okay, so in OAD, in the AOD is AD, so what is the AD equals to the AO plus OD, right? Again, we're using triangle, right? So what do we get? Minus OA plus the OD, right? So what's OD? So in this case, we just reverse it from OD. We already know the OD, right? Okay, so this is the thing we get. Okay, so finally, then we know that what do we get? So this AE equals to the 3/5 AD. So we just bring them in. So here, what do we get? So from here we get this. We get this one, right? OE minus OA equals to what? We're bringing this one, right? So this is 3 times bracket as well. OD plus OA. Okay. Okay, now we find out this. Finally, we found out this relationship, right? Okay, we're using triangle law. So basically, we keep on using two angles. We find out this one. Now we find out this relationship where we're bringing to right up triangle and right up triangle. We use triangle law to simplify them. Then we find out this thing. Okay. Now we find out this thing, right? Okay. Now let's continue. Okay. Now because we already know OA, we already know OD, we already know OA. We also know their equations, right? Only left we need to find out the OE, right? Since the OE is the only unknown one, the rest we all know, so we can find out what is the OE. Okay. Okay, let's remove this. Okay, from just now the calculation, we know that we just bring them in. So OE is AE is OE minus OA, right? Equals to the 3 times OD minus OA, right? Okay. Now we just bring all those items. So what's OA? What is OE? OE is the question, right? OE is the old question, right? OA. Where do you know OA? OA is known. So OD. What's the OD? OD we also know already. D we also know already. And minus this OA is what? What is B? Right? So let's continue. Okay, so find 3. Just do the subtraction inside. So we find out this one, the x component plus x component, y component plus y component. So 12 minus 8, so become 2 minus cancel each other, become 20, right? So this 5 minus 0 become 5. Okay. How about here? Here is xe minus 8 become plus, right? Okay, so what we get? From here we know we just bring this thing, we cancel. Okay, 20 plus. So what do we get? This one cancel each other. Xe plus a and the ye, right? So here, how much we get? How much we get? 12, 3, right? Okay, now we get this. Okay, so then from here we can see that, okay, we can find a formula. Xe plus a equals to 12 and ye equals to 3, right? So continue, come on. What we get? Both sides minus a. How much? 4, right? Ye become 3. Now we find answer. The answer is the coordinate of the ye is 4, 3. Okay, find the answer. Okay, now, okay, this is very clear, right? It's rather wrong, but the idea is very clear. The idea is the clear is okay because the e is on the line of the AED. Okay, of course we also can use the other line, the the BEC to find out this answer. No issue. Okay. In this case, we use, because since these two triangles are similar, we can use either this relationship AED, this straight line, or we can use another way is BEC. But in this case, we use AED to find out the relationship, the coordinate. Since they are sitting on this A and D, we use the known coordinate E and known coordinate B, where to calculate, find out. So now we can work out the what's coordinate of this E. Okay, this is the answer. Okay, now let's move on to the last one. Okay, the last one is what? The last one is find out the ratio of these two. Okay, the ratio, the area of triangle DC. Okay, so this is the two. Okay, now because since we already know, okay, these two triangles, okay, we already know, okay, because so we already know that, okay, this now we remove. These two triangles are similar, right? So if this is the case, so let's work out. So since these two are similar, so just find out one line, okay, in between. So we can use the relationship as AB over the CD. They are the square. Okay, the square of these two. Okay, in terms of ratio of the area of a similar triangles, so we can use this formula. Okay, so just recall this formula. So from here we can straight away answer. So just bring them in. Okay, 3 over, because this relationship, so we know that, so is 3 over 2, right? So what's the area? Area of this ratio? Okay, 9 and 4. Okay, we get answer. Okay, that's very straightforward. Okay, okay, that's all for the example 20. Okay, thanks for watching. Okay, I'll see you soon in the next video. Thank you. Bye.